Hello, we are still dealing with hydraulic system, and this time we are going to add electricity, so it's going to be electrohydraulics. Like the same way we did in pneumatics, we already need to have electrical circuit and hydraulic circuit. So without wasting so much time, I'm going to start with showing you the circuit that we have. We have the circuit. We are going to control our double acting cylinder using a 4x2 directional control valve, and we have the power supply here, like a hydraulic motor, hydraulic pump, electric motor to drive the pump. We have filter, we have tank, we have relief valve, the protection against overpressure, and we have our double acting cylinder with the two limit switches. So we're going to make circuit step by step so that we can be following everything. And before we start before we start drawing circuits, I would also to show you my trainer kit that we're going to use. So this is our trainer kit that we're going to use by simulating electrohydraulic system. And here, the upper panel, this is electrical control room, whereby we start with, here it's the control for our prime mover, and this is the power source for our circuits, 24 voltage and 0 voltage. The remaining here are switches like push buttons, and here are selector switches. Then we also need the relays. These three are relays, but the relays are located inside the panel. Here we can see only the terminals, whereby we have the coils, A1, A2, A1, A2, A1, A2, and these are the contacts for our relays. Then from here we have our directional control valves. You can see this is the 3 directional control valves and another one. And here we have the check valves. We are not going to use them in our circuit. And this is a sequence valve. We are not going to use it in our circuit. And here we have our double acting cylinder with the limit switches. So the limit switches, their contacts are here, are located here. And we have also our check valve, piloted check valve, flow control valve, and this is a hydraulic motor. And that's hydraulic power pack, the one with combining pump, tank, prime mover, and so on. So we are now going to control our circuit, and we start with direct control. Remember, we can have both type, direct and indirect control. Starting with direct control, and I'm going to use GIC standard. We need 24 voltage, and we need 0 voltage. Then our purpose is to control our solenoid so that we can be able to manipulate. So we take voltage for 24 voltage, we pass through switch. I'm going to use push button switch, and we go to solenoid. And let's call this figure 1. Then let us connect the circuit to see what happens, and then I will explain later. My hydraulic circuit is already connected from the back because we saw that in our previous videos. And from switch, I use normal open switch. I go immediately to my solenoid. And from the solenoid, I go back to 0 voltage, as you can see on the drawing. And I need now to turn on. So it's time now to run. We start by running our power pack. So you can see the pressure is changing. Now if we press here, you see my solenoid is energized and the cylinder moves for positive stroke. When I release, my cylinder comes back for retraction stroke. I'm going to do it once again. Like that. So as long as I release, it takes the initial position. Now let's upgrade our circuit to see the figure number 2. Let's say we're going to use indirect control. Again, we will need 24 voltage and we'll need 0 voltage. Then we need again our switch S, and we need the relay. This time we introduce a relay error, and we're going to use a relay to control our solenoid. So a relay has a numeric open contact or numeric close, so this time we select to use normal open contact, and we have to call it error. Then we link to solenoid. And why do we call it indirect control? It's because by pressing on a switch, we'll be controlling the relay directly and the solenoid indirectly. So let's connect it. I also need to plug back my 24 voltage up to switch, and from switch, I need to go to the relay. We say these 3 are relays, so I'm going to use the first relay. And from the relay up to 0 voltage, which is here. And I'm going to connect the second line. So again, it's from 24 voltage. And this time I go to the contact of the relay, which is this one. I can use this. And from that contact, I select the normal open, not normal close, because there we have normal open. From that contact, we go back to the solenoid. And from solenoid to 0 voltage. And we control it once again. I press, it goes on. I'm controlling directly the relay, but indirectly the solenoid. If I unplug here and I press here, nothing is going to happen, because I need to control first of all the relay so that the relay can control for me the solenoid. And this is the most used system, because we can control the relay with low voltage and we control the solenoid with high voltage, or vice versa, we can control the relay with high voltage and we use the solenoid with low voltage. So it will be easier, even if you need to use like a remote control, like touch switches. And we are going to call this, this was figure 2. So let's keep on upgrading. If you realize that while controlling the relay, it has some contacts, and then it closes the contact which was opened, and it opens the one which was closed. So we are going to use this technology to hold the system by saying 24 voltage. And 0 voltage, that's S, that's my relay, and this is the contact for my relay, and that's my solenoid. Let's call this figure 3. So far, the 2 circuits look the same. But I'm going to use another contact for the relay in parallel with the S. And to see what comes out. And immediately, I'm going to connect it to the panel without changing much time. My thing, you remember this is what we came to do. And I'm going just to take 2 wires so that you can see the change. And the wire I'm taking, the first is the wire from 24 voltage and the wire from after the outlet for the switch. So it's like in parallel. So if you plug one here and another here, this is my 2 wires. and then I plug them here on the contacts of a relay. That's exactly what I have. And let me control to see what we have now. You see, this time I can be able to release and the cylinder keep working. And the solenoid is still energized. And the problem is to take it back. Unless I unplug here, which means I have to de-energize my relay. So in order to not to be unplugging, we can add another switch. Instead, we're going to add another switch. Again, we say that's 24 voltage. And that's 0 voltage. So let's call it S1. And we put another switch, S2, but this time this is normal open and this is normal closed. And we put our relay back. Then we're going to duplicate what we have here. Just like that. So remember, what we add is that normal closed switch. And we're going to disconnect this so that we can repeat once again. So we have to move from 24 voltage to S1. 24 voltage to S1. Remember, it is normal open. And from S1 to S2, and this time normal closed. So I'm going to use this switch as S2, and I have to go to normal closed side, which is the contact above. And from that contact, I go to the relay, and from relay to 0. Then I need to put this line. So it is known as hold on, self-holding. Remember, it is supposed to be in parallel with the normal open switch. So I take the two and I put them in parallel to here. Then I go back to the last line from 24 voltage again up to arrow here, and from relay contacts to solenoid, and from solenoid to 0. So we control once again to see what comes out. We press S1, the cylinder goes for extension, and if you need retraction, you press S2. So you can imagine like you are opening a door, you are lifting something, you press for lifting, then you wait, or you press for taking it back, then you wait. So now let's imagine a scenario saying that we have like a gravity feeding magazine, and we need to be pushing away the pieces. And we need, when pressed, we want the cylinder to take it back itself after completing the full stroke. So this is where we are going to use our limit switches. So we need that in case we go for extension, when it reaches here, you can see that it is activating that limit switch. So we need to use this information to bring back the cylinder. And to do this, that's my S1, and that's my S2, that's my relay, and I have the hold on or a safe holding arrow. Then I have the control for the solenoid. So this is figure 5. You can see so far the two drawings look the same. And we are going to introduce now our limit switch so that when we hit the limit switch, we break the circuit. So the limit switch is going to be used as normal closed. There we go. And we're going to write limit switch LS2 to mean limit switch 2. And on our drawing, on our table, this is our LS2 and this is LS1. So this is limit switch 1 and limit switch 2. And what are we going to change from our circuit? From S2 to relay, we have to pass through the limit switch. And remember that this is our relay. So before we enter to the relay, we will have to pass through the limit switch. So I'm going to wear it very quickly so that you can well understand what I'm doing. So this is my cable from 0 voltage and from 24 voltage to switch. From that switch, normal open to normal closed switch. From normal closed switch, remember before we go to the relay, we have to pass through the limit switch, which is exactly this one. So I'm going to use the normal contact, the normal closed contact. And from that limit switch, I have to go back to my relay. And from the relay, I need to go to 0 and I will plug my hold-on in parallel with the S1. And I will have to control from 24 voltage to ARA, from ARA back to the solenoid, and finally from solenoid to 0. And let's turn on to see what comes out. If I press here, the cylinder goes for extension, and when it reaches the end forward position, it comes back itself. We do it once again. See? Just like that. So in case you need to bring it back before it reaches the end forward position, like this, you can just press S2 to take it back. So let's close up for today. And the next video, we're going to upgrade and to make it working automatically. And I want you to be trying to draw the circuit so that we can have the same understanding. Thank you very much.